Assalamu alaikum. This is 11th chemistry, and our today's topic or lecture is about this viscosity. Now, as far as this viscosity is concerned, we know that liquids flow because the intermolecular forces present between the molecules, they are weaker than those of the solids, although these forces are greater in than gases. Now, different liquids have different rates of flow. Some liquids flow rapidly, like we have got water, we have alcohol, kerosene, etc. Whereas there are some liquids which flow slowly, like only like we have got this glycerol, etc. Now, the cause of different rates of the flow of the liquids may be understood by considering the liquids, and it may be understood by considering that the liquids to by considering the liquids to consist of a large number of molecular layers which are arranged one above the other. Now, the molecular layer which is in contact with the ground surface, it remains almost stationary, while the layers or the upper layers, they go on sliding over this layer, over one another. Thus each successive layer above it it moves gradually with increasing speed. Now, the motion of the molecular layers relative to one another, that is between two successive layers, it is opposed by a force of internal it is opposed by a force of internal friction, that is known as viscosity. So viscosity, it tends to oppose the flow of the liquids, and it may be defined as the internal resistance to the flow in liquids, which arises due to the internal friction between these successive layers of the liquid while sliding one over the other. Now, for example, if we select a molecular layer, you can see here this molecular layer, the molecular layer immediately beneath it, or below this layer, you can see here it tries to retard its flow. That is, this lower layer, it tries to retard the velocity of this layer tries to retard the velocity of this layer, whereas the layer above it, that is the upper layer, now this tries to accelerate the flow of the layer. Now, if the velocity or the layer at if the velocity of the layer at a distance of dx, this is the distance between the two layers, dx is distance is changed by the velocity dv. You can see here dv I have shown here. So the velocity changes by dv, then the velocity gradient, it is given by, you can see here, we can write it as dv over, and we can write it over dx. This is the velocity gradient. Now a force, now we can see that this is velocity gradient. Now a force is required to maintain the flow of the layers. Now the force required to maintain the flow in these three layers I have shown here. Then these three layers, it is directly proportional to the area of the contact, that is the contact between the two layers, and also this velocity gradient which is given by dv over dx. So we can write this force, this is directly proportional to the area of the contact between these two layers, and it is also it is proportional to this velocity gradient, that is dv over dx. Now we can write then this force, it is directly proportional to area and dv over dx, or we can write f is equal to this is eta a dv over dx, where this eta, or it is called the coefficient of viscosity. Now if we have got if we have got if area is 1 square meter, and this velocity gradient is it is this velocity gradient, it is given by this by one by unit meter per second, unit or this velocity gradient is equal to unity. In that case we can define this neta, or it is coefficient of viscosity. It can be it is given by, it is the force when the velocity gradient is equal to unity, and the area of the contact between these two layers is also equal to unity. So coefficient of this viscosity, we can it can be defined as the force of friction required to maintain a unit velocity gradient between these two parallel layers of unit area of contact. Now as far as the units of this concern of this viscosity or this or concern, we can say here this is neta is equal to F into dx over A into dV. Now, or we can see this force is measured in dynas, and this dx it is measured in centimeters, and area is again square centimeters. Then we have got dv over this dv, or change in velocity, it is given by centimeter per second. Then the units come equal to dynas per square centimeter and second. So this is also called as, we also called it as second, or and we also call it as poise. This is after the name of this after the name of Jean Louis Poiseuille. Now since as far as these SI unit is concerned, this is CGS unit. Now as far as the SES unit is concerned, the SI unit of this coefficient of viscosity, it is Newton meter square second, or we can also call it as Pascal second. Now as far as the as far as the impact of temperature on viscosity is concerned, the viscosity of these liquids, it decreases with a rise in temperature. This is because with the increase, we know that the increase in temperature, it increase the average kinetic energy of the liquid molecules. Now the increase in kinetic energy of these liquid molecules, it overcomes the intermolecular forces of attraction, and this leads to a decrease in the viscosity. This is about the effect of temperature, that is increase in temperature decreases the viscosity. Then we have got the effect of this the nature of this liquid. Now the liquids which have got so the nature of the liquid also plays an important role in viscosity. Now the liquids having stronger intermolecular forces of attraction have more viscosities than liquids with weak attractive forces. For example, we can see viscosity of benzene. You can see here it is 0.65 into 10 power minus 3, whereas viscosity of this ethanol, it is 1.20 into 10 power minus 2 it is 10 power minus 3. So viscosity of benzene is 0.65 into 10 power minus 3, and while that of this ethanol is 1.20 into 10 power minus 3. Now we see that the intermolecular, since in the intermolecular forces in case of this ethanol are stronger than benzene, it is for this reason that the viscosity of this ethanol is greater than that of this benzene. Now since in case of ethanol we see there is a hydrogen bonding, that is also responsible for it, whereas then we have got then this was the effect of, or the nature of the this liquid. Then we have got the effect of pressure. Now viscosity also increases with the increase in the pressure. Because of the increase in pressure, the molecules of the liquid, they are brought closer to one another. Now since when the molecules come close to each other, the force of attraction increases between the molecules, and this results an increase in the viscosity of the liquids. So this is about viscosity and the factors which affect the viscosity, like temperature, nature of the liquid, and effect of the pressure. So this is for today. Thank you very much.